welcome to our webinar on low-code digital solutions titled MES of the Future with Grantek. My name is Bryon Hayes, and I'm an Industry 4.0 consultant with Grantek. I'll be leading you through the webinar this afternoon. Okay, let's jump into it. So just before we get started, I'd like to offer up a few tips to make sure that everyone gets the most out of our conversation today. First off, I know that it's easy to get distracted, especially because we're all very busy. I mean, some of us are working from home, some of us are in the office. Each of those environments brings its own distractions. Phone calls, texts, chats, they're all hitting us constantly, likely at a mile a minute. So if you can, flip your phones over and minimize your email clients. Find a quiet space and please do your best to stay focused and engaged as you are able. Next, take notes. If you find something we discussed today particularly interesting, jot it down so that you remember it for later. We will be sending out a recording after this, so you will be able to watch and listen again. That being said, I know that I like to drop a few notes in my notebook when I watch a webinar so that I know where to go back to in the recording later. Helps me find those sections that were of particular interest to me. Also, if you have any questions that come to mind as you're watching today, enter them into the chat. Our team will be collecting them for later discussion during the Q&A period, after the presentation portion of the webinar. Finally, there will be poll questions that come up throughout the webinar to keep things interactive. So please answer as best as you can, reflecting your current circumstances as they pertain to today's topic. Okay, let's get to the agenda for today's webinar. So here's a brief list of the topics that we're going to discuss today. We'll kick it off with a short introduction where you get a chance to meet your presenter, aka me. Then we'll walk things back a bit to talk about MES and other digital systems and how those technologies support the concept of smart manufacturing. We'll then discuss MES as it looks like today and some of the opportunities that folks in industry have found with the current generation of platforms. We will walk through some trends that are emerging within the digital manufacturing application space, one of which is low-code development. After introducing the concept of low code, we will then discuss some of the key benefits that it can bring to your factory. Finally, we'll recap our discussion and we'll wrap up with a Q&A session. Okay, introduction time. As I said earlier, my name is Bryon Hayes, and I'm an Industry 4.0 consultant with Grantek. Grantek is a system integrator and business solution provider for manufacturing organizations. We primarily serve the life sciences and food and beverage industries. I've been with Grantek for 22 years. I began my career as a young, fresh-faced engineer straight out of school. My career has grown with the company and has been primarily focused on the life sciences industry, where I've implemented and managed countless automation and information projects. As an Industry 4.0 consultant, I am responsible for delivering high-quality outcomes for Grantek's customers by leveraging my experience and expertise to unlock the possibilities of modern technology. I also try to stay involved in the industry. I'm actively engaged with the ISA as part of the ISA 112 Committee on SCADA, and I'm involved with the International Society of Pharmaceutical Engineers, or ISPE, especially in Canada, where I sit on the board of directors. I've been involved with the ISPE Pharma 4.0 community of practice for about 5 years now as well. Okay, before we get into the meat of the discussion, let's jump into our first poll question. What are you using MES for? Are you not using it, but you're thinking about starting? Are you not using it and not even thinking about starting? Are you implementing a full electronic batch record system or an equipment to ERP integration? Or are you using it for performance monitoring? Or is there some other reason you're using it? Give you a few seconds here to answer the question. Okay, so looks like some of you are using it for mainly performance monitoring. Some of you are using it for other purposes altogether. And there's a few of you that aren't using it, but you're thinking about it. So very interesting. Okay, let's keep going. All right, so now let's talk about digital solutions, of which MES is one, and how those digital solutions support smart manufacturing. So, why might a company with the sole aim of manufacturing and selling some sort of a product to the marketplace implement a digital solution such as MES to support the operations side of their business? Well, one might suggest that the company has been lured by the promise of smart manufacturing. But what exactly does smart manufacturing actually mean? The qualifier smart has been applied to almost everything these days: phones, refrigerators, homes, you name it. So, how can it be applied to something as wide ranging as manufacturing? Well, according to MESA, the Manufacturing Execution Systems Association, smart manufacturing involves the use of technology to improve many, if not all, processes by making information available to speed decision making and, most importantly, to improve the success rate of each decision. That's a pretty good description. It's also fairly high level. Let's dig a little deeper into it. MESA goes on to describe a set of characteristics of what smart manufacturing is and how it might look. Here's what they say. Smart manufacturing is secure. It enables broad, secure connectivity among devices, processes, people, and businesses in the ecosystem, securing data integrity, protecting intellectual property, shielding against cyber attacks, and maintaining business continuity. Smart manufacturing is also orchestrated. It is manufacturing that is adaptive to schedule and production changes with minimal intervention. It allows easy reconfiguration and optimized process and material flows. It's proactive. Smart manufacturing comprises proactive, predictive, and semi-autonomous processes that act on insights, triggering automated decisions in routine situations and personnel intervention in non-routine situations. Smart manufacturing is flat. In a smart factory, resources and processes are digitally integrated, monitored, and continuously evaluated for near real-time insights across a flattened organizational structure and value chain, with more autonomy and faster decentralized decision-making. Continuing on, smart manufacturing is also agile. A smart factory is quick to react to changes in demand. It's resilient to disruption and is capable of maintaining business continuity through adaptability, modularity, and minimal redundancy. It's interoperable. Smart manufacturing involves a connected ecosystem of devices, systems, people, services, and partners communicating in a natural yet structured manner. It works across on-premises, edge, and cloud computing platforms, exchanging information with the broad adoption of integration standards and APIs that enable multi-vendor plug-and-play solutions. And finally, it's a sustainable technology. A smart factory optimizes the use of resources, minimizing negative environmental impact and maximizing positive socioeconomic outcomes. So now that we have an understanding of what smart manufacturing looks like, let's discuss how implementing a manufacturing execution system or other digital solution might unlock the characteristics of smart manufacturing in a factory or across an enterprise. One of the functions of MES is to capture what the manufacturing process is doing or has done. This is inclusive of all industries, whether regulated or not. MES pulls in manufacturing data, processes, and outcomes, enabling this information to be leveraged further. This unlocks many benefits to a manufacturing organization. A well-implemented MES, bought into by the entire organization, helps to improve efficiencies, enables the sharing of best practices, unlocks the possibility for reduced manufacturing downtime, and helps increase the consistency and safety of any non-automated processes. When effectively established, MES enables a paperless and uninterrupted workflow that can maintain a worker's concentration and efficiency during complex and crucial manufacturing procedures. In an article for Forbes magazine, Trond Arne Lundheim describes what MES should be and do to fully unlock the benefits inherent within smart manufacturing. An MES should excel at shop floor management across a wide range of industrial use cases and should optimize the use of shop floor resources, assist with scheduling minute to minute, not just day by day or by shift, and should at the very least be an excellent system of engagement where it ties up loose ends for a mobile workforce along assembly lines, shop floors, or across factories. An MES is typically optimized for complex production processes with frequent bottlenecks, the bane of production lines, limited capacity, a common occurrence, and as a way to deal with alternative paths in production. It should also be a system of record at times, although that role is typically better played by an ERP system. One way of looking at it is by considering that MES software is generally used for the who, what, when, where, why, and how much facets of work order execution. Okay, now that we understand smart manufacturing and MES's place in the mix, let's look at the current state of MES and what is available for manufacturers today. The BioForum is an industry association made up of companies in the biopharmaceutical industry and their suppliers. In 2022, the BioForum Operations Group published their MES of the Future Manifesto, a call to MES software developers to apprise them of the coming needs of their industry when it comes to MES. Their observations around the current state of MES can apply to other industries too, so it's worth going over them. It should be noted that a lot of people in the life science industry equate MES with electronic batch recording, or EBR. EBR is an example of digital traceability of the production process, which is indeed one facet of MES, but there are many more functions available in an MES suite. The BioForum describes the current MES marketplace as dealing in Swiss Army knives, where the solutions are one size fits all, because vendors attempt to make their products apply to as many scenarios and industries as they can. So if you only need one element of MES, you still need to purchase the entire suite. They see MES as being monolithic and inflexible. Any deviation from the traditional process requires extensive customization through software and coding, which is expensive because it requires specialized developers and takes a tremendous amount of time to specify, design, develop, test, and for pharma, validate. They point to MES systems' large footprints in the on-premise infrastructure, requiring integration to both ERP and the plant floor equipment, which requires a large investment to set up and get running. Because of this heavy investment, many companies feel that they end up locked to a single vendor for any changes, troubleshooting, and downstream support. This is a good point to discuss some of the challenges that can arise during MES implementations. In a recent article, Sebastian Casa lists some of the more common issues in MES projects. Regardless of manufacturing paradigm and industry, the first step to a successful MES implementation is proper planning. Without a clear understanding of the project's objectives, resources, and timelines, it is easy to get off track. Some companies rush into MES implementation without first assessing their current systems and processes, leading to poor implementation results. MES implementation involves multiple stakeholders, including production managers, IT professionals, and vendors. Poor communication among these groups can lead to misunderstandings, delays, and mistakes. For instance, the production team might not provide enough information to the IT department, leading to poor system configuration. The IT department may also not communicate clearly with the MES software vendor, leading to compatibility issues. MES implementation can be disruptive, requiring changes to processes and workflows. This can lead to resistance among production staff who feel uncomfortable with new systems and processes. Such resistance can slow down the implementation process or even derail it entirely. This leads to another issue seen in MES implementation, a lack of organizational maturity. If teams are misaligned and the organization isn't understanding of what MES is and does, there can be issues. The foundation of the house needs to be solid before you start framing, and so on. MES implementations rely on the company's IT infrastructure. The MES is where IT and OT converge. If the manufacturing OT infrastructure and the IT infrastructure aren't compatible with the solution being implemented, the project either stalls or becomes a lot more expensive. Similarly, MES implementation relies on accurate data to function properly. If the data quality is poor, the system might produce incorrect or inconsistent results, leading to production delays, quality issues, or other problems. Now let's zero in on two concerns raised in the Bioforum MES of the Future Manifesto. The MES is both time-consuming and expensive to implement. So I'm going to quote Trond Arne Undheim again here, and he states, an MES is typically a rigid system and takes time to customize. The average implementation time for an MES is about 15 to 16 months. Others estimate 6 to 18 months. Custom-built MES configurations based on MES toolkits can run high ratios of license to service dollars, often upwards of 1 to 5. That means for every $10,000 spent on licenses, you may actually be spending $50,000 in services. The total cost of custom-built or off-the-shelf MES is high. There is near universal frustration with MES systems, but up until recently, there have been few realistic alternatives. For those life sciences folks in the audience, the Bioforum also raises some concerns with the overall life cycle. Industry regulations typically require MES solutions to be validated, since they orchestrate the production process and capture production data, and they support the batch record. Validating an MES can be equally expensive and time-consuming. Additionally, new product modalities coming online in the biopharma industry are being manufactured in smaller batch sizes. This means that manufacturing systems need to be highly flexible. There needs to be a quicker and easier way to design, create, and validate recipes. If MES isn't designed in a modular fashion, this can also be expensive and a challenge to maintain as changes inevitably arise. So, based on what we've seen thus far regarding MES systems, and this can be extrapolated to other digital systems as well, does the current software landscape align with the tenets of smart manufacturing? The Bioforum's observations tell us that MES is monolithic, slow, inflexible, and large. MESA says that smart manufacturing is quick, agile, and well orchestrated. So there seems to be a misalignment within the current MES landscape and the promised efficiencies of smart manufacturing. Okay, we have another poll question for you. How long ago, if you've already implemented MES, have you implemented it? Are you not using it, so the point is moot? Have you implemented it within the last year? How about the last 5 years? Or maybe you implemented it over 5 years ago. All right, I'll give you a few seconds here to answer the question. Okay, so not surprisingly, most of you aren't actually using MES yet, but those who are have implemented it within the last 5 years, so relatively recently. Okay, so now that we've understood the challenges, let's look at some recent industry trends in digital systems that attempt to solve those challenges. So just a quick recap. This is a slide from one of our previous webinars summarizing the challenges inherent with traditional monolithic systems. Deployment is complex, and without proper training, the solutions are difficult to use for operations personnel. Using a monolithic system is high risk because you are all in with your vendor. You may get a lot of functionality that you don't need or want, but you have no choice. This leads to vendor lock-in and a set of predefined capabilities that are challenging to modify. You may need to adjust your processes to fit the system instead of the other way around. Because MES is at the intersection of IT and OT, you need alignment of both groups in your organization. This doesn't always happen, which leads to issues. And finally, you end up heavily relying on your software vendor, consultants, and other third-party organizations to support your solution, so you need a well-designed support agreement to ensure uptime of the system. Okay, I think we should stop here and say that there are industries and companies for which large MES works, and it works well. There are many manufacturers who have been using MES in its current form for many, many years and have been successful with it. But for those organizations who feel like they'd like to investigate an alternative, where should they turn? Well, they can search for a platform that supports rapid application development through configuration rather than coding. These platforms are often called low-code or no-code development solutions. Fabio Sala describes low-code development platforms thusly. A low-code development platform provides a unique development environment designed to facilitate and speed up the creation of value-driving software applications. Low-code development platforms enable rapid application building using highly visual graphical user interfaces, drag-and-drop features, and model-driven configuration logic. Anyone with some understanding of computer software can learn to use them, as opposed to traditional hand-coded computer programming, which not only requires much more technical expertise and training, but makes it difficult for collaboration and input from other stakeholders who do not know the specific programming language or coding approach being used. Low-code development platforms are also designed to lower the initial cost of application setup, training, deployment, and maintenance, making their use approachable and affordable to manufacturers and companies of all shapes and sizes, but particularly those who want results fast and don't have the resources, budget, or internal expertise to take on a monolithic system implementation initiative. At the same time, the flexibility and openness of most low-code development environments is not only conducive to future scalability and enhancement, but supports integration with a plethora of external systems and devices, including enterprise resource planning or ERP, and smart devices such as glasses, watches, and tablets. Fabio Sala goes on to list the key principles of low code. It's got a cloud-native architecture to empower your organization to build and run scalable applications in modern, dynamic digital environments. It's open and extensible. Platform application programming interfaces, or APIs, model APIs, and software development kits, or SDKs, for rich extensibility options. Integration with almost anything. It allows scale without redesign. It's designed for growth with a microservice architecture. It operates efficiently and prevents painful re-architecting. It involves collaborative visual development, intuitive development features with built-in collaboration streams help your people create what the business needs quickly. And it's a multi-channel user experience. You can reach users where they are with effortless, stunning applications. You can build progressive web applications or PWAs, hybrid applications, or native mobile applications. And you can deploy them anywhere. You can run applications in any cloud or on premises. Out-of-the-box containers means no extra software development effort. Drone Untime feels that the future of MES lies in low-code solutions. He lists the characteristics of a future MES system thusly. It supports citizen developers. It's composable, which means that it's cloud native, it's built using low or no-code solutions, and it's edge ready. It can be customized by non-specialists. It's enterprise ready, but is also nimble. It can be tailored to be industry specific, for example, biomanufacturing, and it supports the development of a library of apps and components. It's plug and play, so it could be a web app, for example. It's SME ready, or subject matter expert ready, but also scalable to others in the organization. And it's subscription based in its pricing model. So here are just a few examples of low-code solutions for manufacturing. At the top is a screenshot of Cepasoft's business connector, which enables the speeding up of the integration of shop floor equipment to enterprise-grade business systems and takes a drag-and-drop connector approach. In the middle is Tulip's frontline operations platform. It's a cloud-native platform with many pre-configured templates and applications to support a plethora of manufacturing challenges. And finally, there's the Tempo MES platform from Apprentice.io, built specifically for the life sciences market. Full disclosure, Grantek has partnerships with two of these organizations, Cepasoft and Tulip. We have design and development experience with both platforms. Okay, time for our third and final poll question. Does your organization use low-code solutions? Is the term totally new to you? Have you been thinking about it? Do you have some proof of concept projects underway? Or are you extensively using low-code solutions for all of your manufacturing software applications? Okay, I'll give you a few seconds to answer the questions. Okay, so it looks like pretty much all of you are have either not heard the term low-code solution or are thinking about it already. It doesn't look like anybody here has tried implementing any proof of concepts or are using it, fully in their organization. All right. Now let's dive in to discuss the value of low-code solutions. One of the key values of low-code solutions is that they can also be a gateway or an entry point to full MES, specifically for small to medium-sized companies. These companies don't want to start their MES journey by purchasing a full-blown monolithic system with all the bells and whistles. They don't need the Swiss Army knife right away. They need to be able to crawl and then walk before they start running. So low-code solutions, with their ability to start small and scale up, are perfect. And again, with smaller batch sizes and a larger mix of products, these companies need to be nimble, and they need their MES to be flexible and scalable to grow alongside them. There are a multitude of benefits to low-code and hence lower cost platforms. Fabio Sala summarizes them as such. Low skills needed. You can enable your developers with different levels of software development experience, especially those with very little experience, to create applications successfully. Time to run. You can enable accelerated delivery of value-driving business applications. Collaboration. You can enable your stakeholders from different departments and business units to contribute to the development of an application. Cost savings. You can reduce the time, the effort, and the costs needed to develop and deploy smart applications. User experience. You can improve on and innovate upon the application development experience for your software development teams and stakeholders. And continuous improvement. You can give your people access to applications and intelligent data that will help them improve decision-making, optimize business processes, and increase production results across your enterprise. In addition to those, the Forbes Technology Council lists a few more benefits of low-code solutions. Lower barrier to entry, cost, and deployment. And use your subject matter experts to develop the solution. And you can widen the pool of creators to include non-coders. Legacy integration. As technology advances, you can have simpler and more agile interfaces to older enterprise systems become available to you. Speeding up development cycles. You can shorten the time required to develop fully functioning systems. Lower maintenance burden. Low-code solutions abstract the tedious plumbing work and use pre-tested components to focus on the act of creating rather than maintaining. And rapid prototyping. You can create POCs and MVPs, the proof of concepts and minimum viable products, in shorter times and can adjust and rework quicker and easier, so it becomes faster to innovate. So it's also key to note that low code isn't a magic bullet that will let you get away without proper planning, design, and organizational maturity. There are things that you need to keep in mind as you look to move into the low-code paradigm. First off, it's easy to jump in and start creating apps without first thinking about your digital roadmap. This can lead to the creation of multiple, independent, and disconnected point solutions. Your system should be modular, but not siloed. You should be planning ahead for the future so that when you scale up, you don't have to rework what you're building now. It's key that you develop a common plant model, a semantic hierarchy for your business, and a comprehensive data model that underpins everything. You need to have a detailed understanding of your processes to reap the benefits. You also need to build your solution on a solid foundation, with solid plumbing for your data to flow through. This is ensured if you have a robust and secure IT and OT infrastructure. And this is one of the keys to success in any digital project. Finally, there are a number of industry standards and benchmarks available. ISA 88 and ISA 95 have been around for what seems like forever, and there's a reason most people in the automation ecosystem follow them. They work. They're trusted models for the manufacturing industry, so leverage them. Okay, so let's recap. Here are some points you may want to remember and take away from this discussion. Smart manufacturing enables speed and agility and a well-orchestrated process. MES and digital solutions enable smart manufacturing. And they do this by improving efficiencies, reducing downtime, and increasing consistency. Monolithic MES is expensive, time-consuming, and complicated. Low-code and no-code systems offer an alternative. Low-code solutions can be configured by the stakeholders with less involvement from coders. And care must be taken so as not to create siloed point solutions. Finally, leverage industry standard models such as ISA 88 and 95. Okay, so we're going to open up the floor now to questions. Okay, we got the first one coming in. I already have an MES system, but I think there may be a space for low code as well. Can the two exist side by side in my factory? That's a great question. And actually the truth is, or the answer is, of course. I mean, you already may have an MES system, and you may have had it for a while, but then maybe your manufacturing, maybe what your processes have changed over time, and now you have gaps in the functionality of your current MES system, and you can use some of these low-code solutions to to kind of fill those gaps. And they can also integrate, as I mentioned earlier, the low-code systems or solutions can integrate with the fully baked MES solutions, so that you can have a hybrid low-code and full-blown MES. Okay, so just a reminder, in case I didn't mention it earlier, you can type any questions that you have directly into the chat. So please do so if you have one. Next question. Is an S88 batch system an example of low code? Well, actually, I mean, sure, you're basically building your plant model in the S88 batch engine. So you're dividing your enterprise into areas and lines and units and equipment modules and so on. And then you're actually building recipes using a graphical programming or a graphical language like SFCs, basically, where you have states and transitions, and this each state runs a phase, for example, and then when the phase is complete, let's say, you then jump into the the next, through the transition to the next one. So sure, there's it is like a drag and drop system or a program or development environment. So yeah, it can be considered a low code solution. And also, I mean, I mentioned earlier the Sepasoft solution, the enterprise connector or business connector, and Sepasoft also has a batch and procedure module, which is an SCDA batch engine that could also be considered a low-code platform. Speed question number 3. We got another question coming in through here. So how do I go about getting started with a low-code platform? So you still have to go through the the design that you would go through with any software development. Any software development application design project. So you would definitely start with your user requirements, understand what you need or what the users require from the application, and then from that you would identify if low code is indeed a solution for that meets all the user requirements that that are in your user requirement specification. And then you would then look at the various vendors and do select the vendor that most meets the user requirements that you have. And then from there you would maybe approach the vendor, or you would ask them to recommend a system integrator that they're aligned with, that would then help you move forward in your project. And then you would go about the same type of processes that you would for any other software development type of application. Another question here. So for biopharma batch processing, what would be a good facet of MES options to start off with as a proof of concept? Oh, that's a really good question. Yeah, because most, at least in my experience, what I've seen, most folks start out at the weigh and dispense area of their organization. It's one that doesn't involve a ton of, you know, equipment integration. I mean, you're integrating to some scales, and maybe with, within your dispensing suites, the environment, for example, in your dispensing suites, and it's highly, highly manual, where you have to request raw materials. You then have to weigh out each raw material, and then you have a record of each each material and its amount that you've weighed, and so on. So it's usually, at least from what I've seen, the first facet of MES that I've seen for low code. Another one might be, if you have standard operating procedures or work instructions, that you might want to digitize. And this kind of goes hand in hand with weigh and dispense, because it usually follows an SOP or a work instruction. And you can digitize that with a low code solution. So you could even extend this beyond weigh and dispense into something like like in a QC lab or something, like, setting up a piece of equipment to run a test, for example. Or you can even use it for, like, let's say, setting up a fill finish line or something like that. So, making sure that all the equipment or all the change parts you have are in place, and they've already been, washed and autoclaved and made ready to go. So yeah, I think, weigh and dispense and digitizing like SOPs and work instructions. Okay, I got another question here. So you mentioned low code is a faster way to develop. Can you give some examples of rapid application development in low code? Sure. I mean, I can go, I just kind of recent experience using the Tulip platform, for example. So in Tulip, you basically develop, a series of screens with logic to move between them. And in each screen, you can have either a variety of different elements on the screen, like graphics, or, text boxes, or numeric entry or text entry, drop down lists, and so on. And so you can move all these things onto the screen, and you can configure the behaviors of them very simply with, basically without code. So it's all, you could still have some variables, and you can have the variables tied to, each of the different elements on screen. But then to design, or sorry, to implement the functionality of all those, you have basically expressions that you pull down from a drop-down list. And it's so the mechanics of building the application are relatively quick to get started. Of course, you wouldn't just want to jump straight into building an application without properly, maybe wireframing it first, and then defining the workflow that you want to actually have execute in your application. And then, like I said, like have a, potentially like a URS and an FS to define, what the functionality is that you want to achieve in your application. So yeah, that's just a recent experience of mine, leveraging the Tulip platform, which is a low-code application platform. Okay, so I don't see any more questions coming through. So I guess we'll wrap up. So thank you very much for your time and attention this afternoon, and for the engagement with the polls and the questions. You will receive a recording of this presentation for your records. And if you have any further questions, or you want to discuss any further, please email the email address that you see on screen, info@grantek.com. All right, thank you so much, and have a great rest of your day.